Hello and welcome. We've looked into future climate scenarios. Now let's look at past climates. Why? Well, not just because it's interesting, but because we can gather a lot of understanding about the past that we can then use for the future. But how do we collect data about past climates? It's not all that easy. Today, weather data provides us with important information. But since when have we been recording weather data? Well, for the past 300 years, the weather in Europe has been recorded in various places at varying quality and frequency. However, weather data started to be collected more systematically since the beginning of the 19th century. But how do we obtain data that precedes the records? Are there such things as climate witnesses? IJsvermaak, the painting by Hendrik Averkamp, shows people on a frozen canal in the Netherlands in the cold winter of 1608. But nowadays these canals don't usually freeze. Enjoying the ice, just one of many ice-cold paintings of the time, could be evidence of a period of especially cold winters, because all these paintings cannot provide detailed information. Let's go even further into the past. You know boulders, the huge rocks just lying around throughout the northern European and North American landscape. They are mute climate witnesses. They still give us an impression today of the extent to which enormous glaciers pushed them during the glacial periods. But again, stones alone are not enough. They give us too little specific information. However, nature does in fact provide us with climate archives, which can give us more precise information on glacial and interglacial periods. The so-called ocean floor core samples are such a climate archive. Worldwide, we have 3 international core repositories. One in the US, that's the Gulf Coast Repository, one in Japan, the Kochi Core Center, and one in Germany, the Bremen Core Repository. And this is where Professor Michael Schulz works. He's the director of the Marum Center for Marine Environmental Sciences at the University of Bremen. And if you see Michael Schulz standing next to such a core sample in full length, then keep in mind that the upper layer is only a few years old and was formed in your lifetime, and that the other end is almost 600,000 years old. Almost unbelievable, right?